Tonight, I would like to talk to you all about Saturn, and specifically Saturn's rings, or at least that's how I'm going to start us off. So this first picture here, we're up nice and close to Saturn's great rings. You see these banded structures in here. This is an image taken by the Voyager 2 spacecraft. Okay, I got another one too. And this is a picture again of Saturn and its rings, the shadows of the rings on the planet. And this one was taken by the Cassini spacecraft. And the Cassini spacecraft is a spacecraft that it was a NASA mission. It studied Saturn and its ring systems and many of its moons before eventually crashing into Saturn and burning up in its atmosphere. That's going to
Why did people laugh at that?
Yeah. I was really sad that day. That there was a day that
They
happened. Yeah, no, I had a little. I made pancakes in Saturn shape that night.
Oh.
Cassini crash. Yeah. Anyway, yeah, but that's going to be a theme of something crashing into Saturn and burning up. We'll see. Okay, so I'm starting us off. Part of the reason why I want to talk about Saturn tonight is it made me think about when I first started out my astronomy career. I worked at a planetarium, and I was so excited at the time. This was my first real astronomy job, and I was really excited. They were paying me like $17 an hour, which, was a special skilled rate, much more than my just over minimum wage job at Target. So I had made it. But anyway, one day we took some telescopes out to this park, and this is the first time I'd ever actually looked through a telescope. And I saw Saturn that night, and you know what I did? I cried. So this isn't like an exact picture of what I saw, but an idea of what it looked like. Just a little tiny picture of Saturn, but you can see the rings, you're seeing it in real time, and it was amazing to me. So I want to tell you a couple of facts about Saturn's rings tonight. The first one I want to tell you is that Saturn's rings are very thin. I mean, really thin. If they are on average about 10 meters thin, 10 meters thick. So that is, the size of this room. And but they're that thick, only 10 meters, but they are about 300,000 kilometers wide. So if they were as thin as a piece of paper, that piece of paper would need to be almost 2 miles long to be the same scale as how thin Saturn's rings are. Saturn's rings are not one solid body. They're made up of many small particles, and those particles are from the size of a grain of dust all the way up to the size of this building would be some of the largest particles in there. And these are very icy particles, so they're very shiny and reflect a lot of light, and that's why Saturn's rings are so bright and beautiful for us to see. The next fact I want to tell you about Saturn's rings is that they're very young. So Saturn and the rest of our solar system is about 4.5 billion years old. So at first, astronomers would think that the rings of Saturn formed around the same time that Saturn formed, that they'd be, 4 or so billion years old. But that's not the case. Saturn's rings are very young. We are so lucky to be alive at the same time as Saturn's rings have appeared and being so beautiful. They are no older than 100 million years old. So they're so young.
Baby.
Yeah, a baby.
They
Is
probably
that how
get
old your baby is?
almost 100 million years old.
Yeah, you would know, yeah.
I wonder if they get carded.
Yeah, so if you think about that, 100 million years ago, or a little bit, so around that time, there were T-Rexes walking around Earth. They would see Saturn when the rings were just formed, when they were very new. And that's a very recent species in our time, is the T-Rex, right?
And if they started crying, they couldn't even wipe their eyes.
Yeah, unfortunately.
I really like imagining like a society of dinosaur astronomers that's just really cute.
But they couldn't see that comet coming, so.
Yeah. What if they could see it? They just couldn't do anything about
They
it.
couldn't point to it properly.
They what?
Right there. They couldn't. Right there.
Where is it?
You burnt.
Saturn's rings are very young. They formed no later than 100 million years ago. And Saturn's rings form when Saturn's a big gas giant. It's very massive. If something like a comet or an asteroid or a moon gets too close to Saturn, it gets torn apart by the gravitational forces, by the tidal forces. And so that's what forms the rings. Oh, sorry, I'm not ready for that one yet. That's what forms the rings, and they're very dynamic. They're made of all these particles. There's even some moons that carve out some of those gaps in those rings is coming from moons carving them out. And eventually, these little pieces that are forming Saturn's rings that orbit Saturn, they're eventually going to crash into the surface of Saturn. They'll lose some angular momentum, crash into the planet. But as much as the rings are decaying in that way, as that they are losing particles crashing into Saturn, they also can be replenished. So what we're looking at here is a picture from Cassini again, and this is Saturn's E ring. It's one of its more outer rings. And right in the middle here, that little shadow is Enceladus. And so Enceladus is one of Saturn's moons.
Someone from Enceladus in the house tonight?
Must have took a long time to get here.
Boy, are his arms tired.
So that's Enceladus right there. And you can see Enceladus is right in this ring. It's like this ring is along Enceladus's orbit. So let's get a little closer, see what's happening. So let's take Cassini, take a little trip over to Enceladus and zoom in. So this is another Cassini image of Enceladus, and you can see these plumes coming out. And those are these geysers of the subsurface ocean that get pushed out into the solar system and form that ring. So this material is coming out of Enceladus and forming that ring. So although the other parts of the ring are crashing into Saturn, there's always new ways to form rings. There could be another moon that gets too close, another comet that gets too close, or just Enceladus. Later on in my astronomy career as an undergraduate, I took an observational astronomy class, and I had to take an image of Saturn for my final project. And so this is a really special image I want to show you. Those Cassini images are great and beautiful, but nothing like this picture I took on a telescope.
Hey!
Yeah, thank you.
It's come full circle.
Yeah, yes. That was, yeah. So now I think the next question that I'm sure you're all asking is Saturn so special? Why does Saturn have all these rings? Do any other planets have rings? So let's go check. Okay, let's start with Jupiter, another gas giant, the biggest planet in our solar system. And does Jupiter have rings? Yeah, Jupiter has rings. And they're not as noticeable as Saturn's rings because they're made of darker material. They're not as icy and shiny, so we don't see them in the visible light. But if we look with other types of telescopes, we can see Jupiter's rings. Okay, what about Uranus? Yeah, Uranus has rings too. Are we just laughing at Uranus? Like, that's not a joke.
Why are you guys laughing?
I don't get it.
There's no other way to pronounce that. And even the correct way is not funny and doesn't sound like urine.
Also has rings. Okay, next one, Neptune. Also has rings. And shout out to Aman for this picture.
That's my computer wallpaper.
Yes. Right?
Great X-Files.
So actually all the gas giants in our solar system have rings. We're here on Earth looking through our telescopes. It's just like being a woman in your late 20s and opening up Instagram, and all you see, you're like, why does every other girl have a ring except me? Yeah. So, coming back to my astronomy career, grad school. So maybe that's an answer to the last question. So now I'm actually going to switch what I'm talking about a little bit. So in grad school, what I studied were black holes, and specifically like how things fall into black holes, that material around a black hole. So let's take a look. This is a black hole, not a real picture, an artist's depiction, and it looks like it has rings, right? There's this material orbiting around the black hole. And it's very similar to Saturn's rings, that it's material orbiting around it, except instead of pieces of rocks, this is mostly gas that's orbiting around the black hole. And it even can sometimes form in a similar way. So just like a moon got too close to Saturn, got broken up, and forms these temporary rings, we could have a star approach a black hole, and as it approaches the black hole, it starts to get torn apart by the gravity and the tidal forces of the black hole. It's tearing apart the star and forming these rings, or an accretion disk is what we would call it for a black hole. And so this is a temporary event. This is called a tidal disruption event. If a star gets too close to a black hole, gets torn apart. And this accretion disk is all the material made up of the star. And eventually that material will lose its angular momentum and fall into the black hole. Kind of just like the particles in Saturn's rings will crash into Saturn. So to leave us off, I got a couple more pictures of Saturn. And so Saturn's rings are these stunning examples of this physics in our solar system. And yes, I would like to leave it at that. Thank you, guys.